I'm going to show you 3 methods of making your animations more realistic by applying animation curves, otherwise known as timing functions. We'll see 3 different techniques in this video. That's coming up. Hello, my name is Alex, and this kind of movement looks robotic and unnatural. And that's the same way that using default animation curves or linear timing functions looks in user interfaces. So today we're looking at timing your animations so that they look more realistic and natural. And this is important in user interfaces because it helps the user to connect with your app. I would even go so far as to say that the app becomes more enjoyable to use if you're using natural curves. Now, I've shown how to use animation curves before on this channel, but today we'll go through 3 different ways that you can change the swing of the animation by setting its curve or timing function when you're creating the animation definition in your JavaScript code. We're gonna start off nice and easy with timing functions that pretty much everybody using NativeScript should know by now. And then we're gonna get progressively more complex. And even if you're a seasoned advanced user, you should really see the 3rd option because we're really gonna get into some serious math here. I'm not gonna make you solve any math problems, don't worry though. If you're not subscribed to this channel yet, please consider subscribing and don't forget to hit the little bell so you don't miss any of the tutorials that we've got coming up. I hope you got your coffee ready because we've got a lot of information in this tutorial. All right, let's get into it. I'm starting off with the Hello World template here, and I've cleaned this up already a little bit. I've also added this on-tap handler to our button there, so that button will trigger this on-tap function right here when tapped in the code behind file for main page, and we're gonna grab a hold of the view, which is that button itself. Now we need that view so we can get to the page. That's the page that the view lives on. And then we're gonna call getViewById because we wanna animate some view. So what view do we wanna animate? Well, I'm gonna animate this label right here, which is the message. And that's this label right here that says 42 taps. So we can see it a little bit more clearly. I'm going to add an LBL class to that label. And let's go to app.css and add LBL down here with a background color. Let's make it blue violet. That's fine. I'm going to open this up a little bit so we can see the simulator at the same time as our code. And let's close this up. Okay, so you can see a blue violet label there. We actually don't really need the text inside, so I'm just going to leave the text blank like that. We only need the colors so we can see it animating. All right, now when we tap the button right here, I want to see this label animate. In order to get a hold of it in the code behind, I need to give it an ID. I'm going to give it an ID of LBL. And let's go back to the code and we're going to say view page getViewById LBL. I'm going to grab a hold of that right there, cast it as a view because all views can be animated. And I'm going to call it the target because we're animating our target. We're going to start off with the NativeScript APIs for our animations. And we're going to take a look at what easing functions are available on that first. And then later we're going to expand on that and show you what other easing functions are possible. You can really come up with any functions you want. So let's do a quick, simple example. You've probably seen this before. We're going to use the NativeScript animation API here. I'm going to say target.animate, and then I'm going to press Control Space here because we're using TypeScript. You can see all the different properties available here. Let's animate its height. It's a relatively new property that you can animate. I'm going to go to 400 over a duration of, let's give it 3 seconds, 3000 milliseconds. And let's give it a curve. If you take a look at the curve API, you'll see that it's of type any. And the reason for that is because curve can be a number of things. The comment here says that you can use the animation curve Enum. So let's go ahead and import that. Import animation curve, and that's going to be coming from TNS core modules, UI enums, and that's animation curve. There we go. We can write a string here. We can say linear, for example, and that'll animate. Let's go ahead and test this out. I'm going to tap this button and you can see that our label animates its height in a linear way. Now you also saw a little jump there. That's because the API makes that space available for the label. For the 400, that's the final result for the label height. It makes that space available and then animates the height of the label inside of that space. And the reason for that is to minimize the layout thrashing that happens if you're animating height and width I won't get into layout thrashing in this video, but if you want to know more, let me know in the comments down below. So let's say we want to change the behavior there, and instead of expanding from the middle, we're going to want to expand from the top down. So all you got to do is just say target origin Y, set that to 0, and that's going to set the origin of the animation to the top of the label, therefore allowing it to expand down. So if I tap on this now, you'll see that that linearly animates down. Okay, so that's linear. Now there's other ones there available, and if you don't remember them all, then use the animation curve enum. If I say animation curve dot, then you'll see all the different ones available here. Spring, linear, ease out, ease in, ease, cubic Bezier. Okay, so a lot of people are confused what ease in means and ease out. These are confusing terms, but let me just make it real simple for you. Ease in means it's going to start out slowly and finish quickly. So if I select that, you'll see that when I tap this button, it's going to start out very slowly and speed up towards the end of the animation. Ease out is the exact opposite. Ease out means it's going to start out quickly and then slow down towards the end of the animation. And guess what ease in out means? Ease in out means it's going to start out slowly, speed up towards the middle of the animation, and then slow down towards the end of the animation. So this is kind of a more realistic approach to how objects move in the real world, right? By the way, there's another one called ease here, and this is very similar looking to ease in out. And in the comments here, you'll see it says specifies the transition effects of a slow start, then fast, and end slowly. It's exactly what I just said for ease in and out. And you can even see the Bezier curve down there. It says 0.25, 0.1, 0.25, and then 1. Now the other curves here don't have the values in the comments. But what do these numbers mean? This cubic Bezier and the numbers there. Let's select ease and you can just visually compare it here in the video. So you can see that it starts out slowly, speeds up towards the middle, and slows down to the end. So again, what do these mean, these values? There's a tool that I've showed many times here before called cubicbezier.com. And you can see these numbers here, cubic-bezier. Basically, these are CSS timing functions that you can use by providing values. So for example, here you can select different easing functions to test out from the library that are predefined for you. And here's linear. If I click go here, you'll see the animation example, and a little green square moves with the linear function right now. And the graph here shows you how the animation will take place. So the red one right now is the one that you can control right here with these levers. So for example, for the green one, if I want to say compare ease in out to the one I want to create here myself, and I can click go to test them out, you'll see how they operate. So right now, my red one is exactly the opposite of ease in out. Ease in out, remember, it slowly starts, then speeds up, and then slowly ends. Whereas mine speeds up in the beginning, slows down in the middle, and then speeds up towards the end. So it's exactly the opposite. If I run this again, you'll see that it's got a little swing effect there. And I can toggle these little levers here to kind of draw the animation curve how I like. This one is more of an exaggerated ease in out. If I play this here, you'll see that it's a kind of a spring almost, like a slingshot effect. So what do we do with these numbers here? Can we use them in our NativeScript apps? Yes, we can. I'm going to copy this right here. And then instead of an animation curve that's already predefined as an enum, we can use a cubic Bezier. Well, let's say animation curve, cubic Bezier, and then I can provide the values right here. So I can just copy and paste the ones that I just created right into here. I'm going to save this and let's get our app open again. I'm going to hit tap here and you'll see that we have that animation that we've just defined, that slingshot effect. So you can design your own cubic Bezier animation curves. And this is enough for most applications, but there are times when you want to have a lot more control over your animations. And also, there are times when you want to animate properties that are not animatable through the NativeScript API. So the animate function here and the animation API allows you to animate only certain properties. Like I said before, I can hit Control Space here and you'll see what properties we can animate. Background color, opacity, rotation, scale, translate, and width being some of the other ones you can animate, but not all the properties. And that's why I created that video on JavaScript animations and how those can be used in NativeScript apps. If you haven't seen that, I'll link to it in the video here, or you can check it out on my channel. So I'm not going to go through building that up here in this video. We're just going to use it. So I'm going to create a file here called animation helpers, and I'm going to paste in the code here for the animation helpers. I'm just going to roll through this so you can see it, but I'm not going to explain how to build this up. If you want an explanation on how to build this up and what every one of these little pieces is doing, go check out that other video on that. All right, so we're going to use that now to do our animation, and we're going to specify our animation curve, and we're going to use very specific functions for that, not just the ones that are predefined here. I'm going to comment out our NativeScript animation API animation. And now let's go ahead and animate using the new animation helpers. So first we need to create a definition. This is going to be a JS animation definition type that gets automatically imported. Now, what do I need to define here? First, I need to define getRange. GetRange is a function that's going to return to us a to and from. So we're going from a number, a value that we want to animate from. And let's say we want to animate that label from a height of 0 to a height of 400 like before. Now the label doesn't start at 0 because it already has a height. I'm not going to bother with that for this demo, but it's not going to be 0 in the beginning. It's going to be like, I don't know, 30 or 40. You know, let's just do 40. It's close enough. You probably want to grab the initial height of that label to start with. The next thing we're going to need to do is define the curve. And here is where things get really interesting. Now, I'm going to define a linear curve. What does that mean, linear? Linear means it's a graph that looks like this. So it's just a straight line that goes one up and one across, one up and one to the right. Basically, it's a linear function, and that means that it's a t to t function. So for the curve, you need to provide a function that takes t, which is a time period of the animation. So for every tick of the animation, for every frame, it's going to provide a time at that frame. You need to take that t and do some kind of math with it and return a new value based on that time. We'll start out with t to t. And the next one is the step. So the step will be a function. It's going to take the current value of whatever we're animating. So in our case, we're animating height, and these are the values that we're providing. We're starting at 40 and we're going to 400. So V is going to be somewhere between 40 and 400 based on that time. So what we need to do is say target.height, and we're going to set it to V. All right, so pretty simple. Now we just need to call our animate function over 3000 milliseconds, and we're going to pass in an array of these definitions. So we only have one definition. If you have multiple ones you want to simultaneously execute, you can pass that into the array as well. By the way, this animate function is not the NativeScript API animate function. It's the one that comes with the animation helpers right here. Okay, so I'm going to save everything and let's take a look at the result. I'm going to tap on the button here and we'll see that there was a little jump in the beginning, and that's probably because I didn't get the height exactly correct. That's okay. For demo purposes, that's fine. But the thing to pay attention to is that curve, that linear curve. So that was a perfectly linear animation. It's fine, pretty boring for most scenarios. You probably want a more natural motion. What does it mean to be a square curve? Well, a square curve will take t and it will return t times t. What does that mean? How is that going to look? Well, for every frame, this thing is going to increase the speed 2 times. It's kind of hard to explain that. Let me go ahead and tap this button and you'll see. So this is going to animate and speed up. It's going to speed up as the animation progresses. We don't have to stop there. We can cube this. So t times t times t. That means the acceleration of that animation is going to be even faster. So I'm going to hit tap here and you'll see that it's going to start out very slowly and then it's going to speed up. Now, of course, this is where the power comes in here because you don't have to stop there. Here is an example of, I don't know what that's even called. T to the power of 6, I guess. Let's go ahead and hit tap. You'll see it start out very slowly, and then it's going to speed up really fast. So you can see that by controlling this curve function, you really have a lot of power. Now let's check out some functions that are available that are kind of pre-designed for you. Let's go over here to this gist that I found. Pretty cool gist by this person, GRE, on GitHub. I really don't know who that is, but thanks for this post. Here we have an easing.js class. You can import this into your own projects if you want. Basically, this defines different predefined easing functions that you can use. So here's linear, T to T. Here's easing quad. What did I call it before? I called it square. Okay, well, it's not square. It's quad when it's T times T. Now here's ease out quad. Remember, ease in is the one that slowly speeds up. We saw examples of that. Here's ease in cubic. We saw an example of that, T times T times T. And then we did a quart, and then we did a quint, and we went even further than that. Now, the out functions are pretty interesting here. You can see that here's an example of one. Let's check this out. I'm going to copy this, and let's just paste that function right in here. Oh, too many arrows. Okay, there we go. So there's a function. Let's check this out. I'm going to hit tab here, and you'll see that this speeds up and then slows down towards the end. So this is an ease out curve, and you can see that by the way it looks. And of course, there it is. It's called ease in out quint. So that's not something that comes in out of the box. You have to create some kind of curve for that. Of course, you could use the cubic Bezier to simulate that. In fact, that's what we did here. With this very curve right here, we have a similar result where we have this slingshot effect. And that's kind of what ease in out quint does. But this set of functions is not the only thing you can use. There's a library called D3Ease on NPM. So let's go to NPM and search for D3, which is a really popular animation library. And there's D3Ease, which is a separate package. It's downloaded weekly almost 1 million times. So you can install it, and we can use this in our NativeScript apps because all it is just JavaScript functions. You can see examples of this right here. Here's D3Ease linear. And you even have graphs on what this looks like. So they call their ease in out functions a little bit differently. They call ease poly out. So they don't bother with the names like quad and cubic and quart. They just call it poly because, well, you have lots of different options there. Here's poly exponent, and you can just pre-configure your exponent that way. The interesting ones that I'd like to show you are down here. So we get into trigonometry functions here, and then we get into really exponential ones here, circles, and then check this out. We have elastic functions. What does this look like? Well, let's check it out. I'm gonna hit on this source link right here, and we'll open up this source in GitHub, and you'll see that we have the D3Is library and then elastic JavaScript code right here. And here is the actual code for the elastic in function. And you have elastic in, elastic out, elastic in out. Let's take one of these functions and see if we can just use it. I'm going to copy that body right there, and let's go over here and paste this function in. Now they do have some constant called tau here. I'm not sure where that's coming from. Here we go. So they have these constants predefined up here at the top, something called tau. I'm not familiar with math enough to know what that is. I guess it's 2 times pi is tau. Okay, so we have our elastic in out. I'm going to copy that, and instead of this curve, I'm just going to paste in elastic in out right there. So let's go ahead and save that and check this out in the simulator. I'm going to hit tab here, and we have an elastic animation. Very cool. So look at that. Something you really cannot get out of the box with NativeScript. So this is pretty powerful. Now you don't have to always go and copy paste your functions from here. You can just import this library. How do we do that? I'm going to open up the terminal here by pressing Ctrl+ in Visual Studio Code and just say npm install d3ease -- save. So that's going to add that library to my package.json file. So let's take a look at package.json, and you can see that d3ease was installed. Now, when I install new packages, I do like to restart my project, rebuild it, and restart the simulator. So I did that. Let's go back up to the top here and say import something from d3ease. Okay, so let's take a look inside here. I'm going to press Ctrl+, and unfortunately, we don't have any help here. That's because the D3Ease library doesn't come with TypeScript declarations. But we could keep using this as a JavaScript. We don't need to import TypeScript declarations. But if we did want TypeScript declarations, not a problem. Let's go to package.json, and under dev dependencies, I'm going to just add @types/d3ease. And the version is 1.0.9. There we go. let's just go ahead and pop open the terminal again. I'm going to say npm install, and that's going to grab that TypeScript package for us, the TypeScript declarations for D3s. So now if we go back to our main page, I'm going to say control space here, and look at that. Now we have declarations for everything here. So you can see we have all these different interesting functions to discover and things you don't have to write because these are already written for you. All we did was just import all of them, and now you're free to use them. So let's check out this ease bounce out. I'm going to go ahead and copy that, and let's go to our curve here and use ease bounce out instead. Let's save that and let's test this out. I'm going to hit tab here, and we got a little bounce going on. Very nice. All right, so now that you've learned a lot more about animation timing functions, next week we're going to apply this directly in a tutorial that I've got coming up. It's going to be pretty cool, so subscribe if you're not already subscribed. And if you want to learn more about NativeScript, whether you're just starting out or you already have a NativeScript job, you might pick up a thing or two by checking out the NativeScripting courses that we have. We have free beginner courses and pro advanced courses. NativeScript Angular, NativeScript Core, and NativeScript Vue are all covered. Check out nativescripting.com. You'll find some details down below in the description with a discount code. You can reach me on Twitter. I'm at @DigitAlex over there. And I'll see you all in the next video. Happy NativeScripting. And today we're going to And today we'll go three, and today we'll do three, and today we'll, what? And today we'll do other 3 different ways, but today I'll show you 3, but today we'll go through 3 different ways that you can change the swing of the animation